All right, go on to the next graphic. We're going to do some more special factoring here, and the next category of special factoring is what is called the difference of two perfect squares. And these usually factor into conjugate pairs. And I want you to write that word down, conjugates. C-O-N-J-U-G-A-T-E, conjugate pairs. The conjugates are going to be your friend, believe it or not, later on in the course. All right, now what makes something the difference? Remember what that word difference meant from way back? It means subtract, and you're going to have some perfect square subtracting there. So a square minus b square will factor into a plus b times a minus b, and that is called conjugates. All right, so let's go to some examples there and we'll look at them. All right, so notice I wrote easy to recognize these difference of two squares. One, you always got the difference sign between them. And then two, you always got the two perfect squares. Now this is a little different than the trinomial square because when you break them apart, watch what happens. The first two terms to get 4x squared will be 2x, 2x. Now to get the minus 9, so you can't put plus plus or minus minus in here, so you won't get two of the same things. To get a minus 9, the signs must be opposites, right? Because then you can put plus 3 times a negative 3 will multiply to give you that back. So notice on these conjugates, the O and the I part of FOIL go out. So I have a little saying on these whenever I multiply together or whatever. Remember when we were multiplying these and foiling these way back, we said FOIL went to Florida? That's what happens there. We just multiplied the first two and the last two to check that, if you remember in previous lessons. All right, next example of difference of two perfect squares. Break that apart. To get 25a squared, the first two terms, what times what gives me that? 5a times 5a, which I like lots of a's in my classes. Signs, plus minus, to get that minus there. And to get the 16b squared, 4b, 4b. Now, obviously, we can't write 5a plus 4b quantity squared here. Why? Because, well, they're both not pluses. So these are what are called conjugates. Everything's the same except for one term signs. Check that out. All right, but easy to recognize. Let's try some more. Oh, Young, not again. We just don't do the easy ones again here on the BCC network. We keep telling you, we bring it on. We bring it all on, fractions and decimals in one. Are you shaking? Are you going, Mama, Mama? Don't do that. We'll do it. All right, so go ahead and break this apart. To get 36 over 49, those nice perfect square numbers, even with fractions, it will come out 6/7, 6/7, C, C. All right, signs, plus, minus. And to get a 0.16, we haven't talked about perfect square decimals yet, but notice perfect square decimals are kind of like what numbers? There's those perfect square numbers again. So you will get plus 0.4d minus 0.4d. And if you multiply 0.4 times 0.4, you get the 0.16 back, d squared. So fits like a glove. Again, conjugates. All right. Now, how about this bottom one? A lot of you might say, oh, Young, difference of squares, you could go ahead and start breaking them apart. And when I do the difference of squares, this is one of the rare times I don't put it in descending order. If it's, you know, this one, if it's like this and you recognize the difference of squares, leave it alone. I don't even mess with descending order on these. I just kind of take them right on down the line. But there is a danger here. What? There is something in common, ladies and gentlemen. You can take a 9 out of each one of these. And remember, I tried to hit you with one of those early. Be careful. And if you take a 9 out, you can divide each term by 9, and you're left with 9 minus x squared, taking the 9 out. All right, now notice here, that is again the difference of two perfect squares. So I'm going to leave that 9 I factored out there, and then get to the conjugates from here. So what times what gives me 9? 3, 3, plus, minus, what to get the x squared? X marks the spot. Yeah. Okay. So go ahead and leave those in numerical order. I like the way they break apart here, the conjugate pairs. Yeah. Now, what would have happened if I didn't take the 9 out first, and I would have come over here and made the mistake? I would have had 9 plus 3x times 9 minus 3x, and I bet you all see some things in common you can take out to get to this answer. Yeah, so be careful. There can be nothing in common in these parentheses. Yeah. All right. beware. You know, they say, this is pretty easy, but there are ones they try to trick you. How can I factor this? Is this the difference of two perfect squares? The word difference meaning what? That ain't no subtract. That's an addition sign. This is the sum of two perfect squares, and in the real number system, well, we can't really do this. We can't factor. Now, some of you say, dang it, Young, I'm going to factor that. I'll show you I can factor it. And you'll go x plus 3, 3. But when you FOIL that back, I'm going to say, look, the outside's plus 3x, the inside's plus 3x. Where's your 6x up here? And you'll go, dang it, Young, I'm going to factor that. I'll show you I can factor that thing. And you'll go x minus 3, 3. That gives you a plus 9 when I FOIL it back. I'll show you I can do this. But when you FOIL it, I'll say, hey, here's a minus 3x minus 3x. I'll say, where's your minus 6x? And then you'll say, I'm going to factor it, Young. I'll show you. And I'll go x plus 3, x minus 3. I'll put my conjugates, but I'll say, but when you FOIL that back, what kind of 9? Cannot factor that thing. People try. This is the most tricky thing in algebra. Cannot factor. There is no rule to factor the sum of two perfect squares. So beware. Now, would an instructor try to do that to you? Would you think some instructor would try? Oh, yeah, they would try. And they will smile and go, and they got you. So be very careful. All right, let's try some more. Now, some of you are going, wait a minute, Young, that's no difference of two squares. 2 is not a perfect square number, and 32, that's not a perfect square number. We're talking about the difference of two squares here, but don't forget that first and foremost rule of factoring out there, folks. That greatest common factor must come out first, which is a 2. So if you take a 2 out, what are we left with? A to the 4th minus 16. Now, it looks kind of harmless, doesn't it? It's like, all right, the difference of squares, now I see it. But this is another one where instructors will go, if you're not careful. Now, watch what happens. We can break that apart, and to get the a to the 4th, y'all know it's going to be what times what? A squared, plus minus 4s. All right, and then you'll go on to the next problem on your merrily way, and the instructor that's been doing this in the background will now go, they're mine, I have them, and they'll go, wrong. And you'll get it back and go, but anyway, what happened here is when you factored the difference of squares, you have yet another difference of squares here. A squared minus 4 will still factor. And then some people will try to do this one, but we have found that if that's a plus sign, don't go there. That's a dark place. You don't want to go there. This one will not break apart, but this guy you must keep going on to completely factor. So another instructor favorite here, AA plus minus 2, 2. So boy, look at this one. You got a lot of factors here in the bottom. Yeah, see, so when you factor these difference of squares, watch out. Watch out. They can happen more than one time as you do them. All right, let's go back to the graphic now. And